So let us discuss about enthalpy of solution, enthalpy of dilution, and enthalpy of hydration, and also lattice enthalpy. Now, enthalpy of solution, very simple. Let us take here some water. Take water. And add some salt. So I am taking any salt, CuSO4, let us take. CuSO4 is a salt. So CuSO4 is a solid or a liquid?
Liquid, sir.
Soup, it is a solid.
Solid, sir.
Okay. Now, enthalpy of solution means, listen very carefully. CuSO4 solid plus water. I can say aqueous. Shall I write aqueous? Use raised to. Is it okay? Large amount of water. Aqueous. Now it will become CuSO4. Help me.
Dot
Aqueous.
5H2.
Aqueous. This is enthalpy of solution. What is this called?
Enthalpy of solution.
Enthalpy of
Solution. Is it all right? Now
Yes,
listen
sir.
very carefully. Listen very carefully. Now, there is CuSO4 here. Now add here water. Now, CuSO4 is a solid or a gas? Solid.
solid, sir.
Next, 5 water molecules. It gives rise to CuSO4 dot 5H2 aqueous. Are you following? Are you
Yes,
following?
sir.
This is
Yes,
called,
sir.
listen carefully. This is called enthalpy of hydration. What is this called?
Enthalpy of hydration.
Hydration. When you listen only, you'll understand. Otherwise, you don't understand these things. Listen carefully.
So then
Now-
what's the difference between enthalpy of solution and enthalpy of hydration?
You listen. Enthalpy of solution is large excess of water.
Okay.
Here, few water molecules.
Okay, sir.
Clear? Now,
Yes, sir.
another one I am teaching. Another one I am teaching. Now, CuSO4 dot 5H2O you take. Okay? You put it in water. What will you get? CuSO4 dot 5H2O plus aqueous. What do you get? CuSO4 aqueous. This is called enthalpy of dilution. What is this? Enthalpy of dilution.
Enthalpy of hydration.
I have understood these 3 formulas first of all.
Yes, sir.
You understood this? This is one episode.
Last one. Last one.
This is enthalpy of
Enthalpy
dilution. Dilution. This is enthalpy of hydration. This is enthalpy of solution.
Solution. And this is direct.
Clear or not? All of you.
Yes, sir.
Yes,
Now,
sir.
Yes, sir.
enthalpy of solution is equal to enthalpy of hydration plus enthalpy of dilution. Shall I explain?
Yes, sir.
Yes,
Now
sir.
listen. CuSO4 solid plus 5H2O gives rise to CuSO4, help me, dot
Dot
5H2O
5H2O.
Dot 5H2O.
aqueous. Clear? So what is this called? Enthalpy of hydration.
Yes, sir.
Right, Olina?
Yes, sir. Yes, sir.
Hydration.
CuSO4 dot 5H2O solid, sorry, aqueous plus aqueous gives rise to CuSO4
CuSO4 plus aqueous.
aqueous. Okay. So now add these two. Add. When you add here, what do you get? Listen carefully. This gets cancelled.
Yes, sir.
Yes, sir.
Agreed or not?
Yes,
Now what do you
Yes,
get?
sir.
CuSO4
CuSO4 plus 5H2O.
solid. Listen carefully. 5H2O plus aqueous. In the water, this is aqueous. Add 5 drops of H2O. What happens?
Aqueous only, sir.
Aqueous only, sir.
Aqua, sir.
Very good. Aqueous gives rise to CSO4 aqueous. What is this called?
Enthalpy of solution.
Enthalpy of solution.
Enthalpy of
What is this
solution.
called?
Enthalpy of
Enthalpy of formation.
enthalpy of dilution.
Dilution. What is this called?
Enthalpy of
Enthalpy of
hydration.
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 Now you are clear or not?
Yes.
Yes, sir.
Yes, sir.
You're clear or not?
Yes, sir.
Yes,
Sir,
sir.
what is the difference between enthalpy of dilution and enthalpy of solution, sir?
Enthalpy of dilution means you take some salt with the hydration, water of crystallization,
Yes, sir.
and then you add aqueous. Now here you are using, what is this salt? Anhydrous salt.
Yes, sir.
What is this salt? Hydrous.
Hydrated salt.
Hydrated. So hydrated salt, you are adding water.
Yes, sir.
Anhydrous salt, see this is, sorry. Anhydrous salt, you are adding water.
Yes, sir.
So anhydrous salt, when you add water, you get enthalpy of solution.
Yes, sir.
So hydrated salt, when you add water, you get enthalpy of dilution.
Yes, sir.
It's a good question. Nice. I hope you're all clear.
Yes, sir.
So
Yes, sir.
3 topics I've completed at once. So actually it is difficult to understand. If you listen to the teacher, it's easy. Now, NaCl, water molecule, enthalpy of solution. This is enthalpy of solution because you added in large excess of water. When you add large excess of water, what happens? This will be dissolved completely. Agreed? So its solution may be exothermic or endothermic because some salts are exothermic, some salts are endothermic. For example, take glucose, add water, put your hand in it. How it looks, hot or cool? Use soup. It's hot or cool? Arey, you never tried, eh?
Sir, cool, sir.
Cool only. Take
Cool,
some take some calcium carbonate powder.
Sir, it will be hot, sir.
Hot,
It
sir.
will be hot.
Hot,
Yes, sir.
So-
During painting of the walls, they do that.
Exactly. So dissolution by, see, a salt will be there is a dissolution takes place by the evolution of heat. Dissolution takes place by the absorption of heat. That's why enthalpy of solution can be exothermic or
Endothermic.
clear or not? Now, here it is given the definition. It is given one word is there. Infinite dilution. Can you see? Have you seen infinite dilution here?
Yes, sir.
Why infinite dilution? You're adding large excess of water.
Large
Aqueous, na? You're adding large excess of water, na?
Yes, sir.
That's why it is infinite dilution. Am I clear or not?
Yes.
Yes, sir.
So it is also hydration energy and lattice energy. Enthalpy of solution is also hydration energy plus lattice energy. See, I'll ask you one question. When there is a when can you say salt is soluble? When the
Sir,
hydration energy is greater than
Greater than lattice energy.
lattice.
Lattice.
lattice energy, dissolution takes place. What takes place? Dissolution takes place.
Dissolution.
Dissolution takes place. Clear or not?
Yes, sir.
Yes, sir.
Now listen, very interesting. Now, what is this step is called?
Sir,
What is this step?
enthalpy
Sir,
of
it's enthalpy of hydration, sir.
Very good. It's a hydration step. What is this step called?
Enthalpy of dilution. Sir.
dilution, sir.
Very good. What is this step called?
Sir,
Enthalpy
enthalpy
of
of
hydration.
This is hydration. Huh?
Solutions.
Yes, sir.
This is 7, not aqueous. This is aqueous is given here.
Yes,
So this is
sir.
enthalpy of solution. This is enthalpy of
Solution.
Solution.
solution. I hope you understood. So enthalpy of solution is equal
Yes,
to
sir.
hydration plus dilution. Clear or not, all of you?
Yes, sir.
Yes, sir.
Okay. Now, so question is given. The enthalpy of solution of anhydrous CuSO4 and hydrated CuSO4 are, that means, listen carefully. Listen carefully. Anhydrous CuSO4. Anhydrous CuSO4 means this one. Agree or not?
Yes,
Plus
sir.
Yes,
water.
sir.
What is this called? What is this called?
Solution, sir.
Excellent. This solution. Next. Hydrated CuSO4 H2O. What is this called?
Dilution. sir.
Dilution.
Dilution, sir.
Dilution. Very good. Now, what do you have to calculate?
Enthalpy of hydration.
Hydration. sir.
Enthalpy of hydration.
So solution is equal to
Hydration plus
Hydration.
dilution.
Hydration plus
dilution.
dilution. sir.
dilution. So what is the question? Hydration you have to find. So how do you get the answer? Solution minus
Solution
Solution
minus
minus
dilution.
hydration.
dilution is equal to
Hydration.
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 So this is the answer. So see here, what is done here? What is done? Minus 66.5 is what?
Solution.
Solution.
sir. Enthalpy of
Solution. This solution, na?
Yes, sir.
Yes, sir.
What is this?
Enthalpy of
Dilution.
Dilution, sir.
Dilution.
Enthalpy of dilution.
You will get a. Mind you,
Enthalpy of
please.
hydration.
Enthalpy of hydration is always exothermic. Hydration is always exothermic. Na? Hydration energy is always the amount of energy released when an ion gets solvated. Here, it is always amount of energy released means what? Released is exothermic reaction. So here you got exo or endo answer.
Exo, sir. Sir.
So, sir.
Exo only. Any doubt regarding this? So now,
No, sir.
if any question associated with enthalpy of solution, enthalpy of hydration or dilution are given, so you should answer properly. Can you see a question now?
Yes, sir.
So NaOH plus 3H2O gives rise to NaOH. What is this called? Enthalpy of solution.
Enthalpy of solution.
Solution.
What is this called? This is enthalpy of solution. Or, one second, one second.
Enthalpy of hydration.
Now, what is this step? First step. Three water
Solution.
molecules. Three water molecules is enthalpy of hydration, na? So this is hydration, na?
Sir, but
Three
it
water
is
molecules,
from
right?
hydrated product, na, sir.
Downward is also hydration only.
This is infinite, na? 300 molecules. Use soup.
Okay.
Sir, that is
Okay.
solution.
This is solution.
One solution.
This is solution.
Yes.
Clear or not? Yeah. This is hydration. This is solution. What do you have to find?
Dilution.
Dilution.
You have to find. So how do you find it? Formula.
Sir, solution
Enthalpy of
minus
solution.
Solution minus
Enthalpy of
hydration.
solution
Minus enthalpy of
minus
hydration.
enthalpy of hydration.
Enthalpy of dilution.
Yes, sir.
Hydration is equal to enthalpy of dilution.
Dilution.
So solution minus hydration. This is solution. This solution, na?
Yes, sir.
Minus
Yes,
this.
sir.
Minus
Hydration.
28.9. Use minus 13.4.
Minus
Am I right?
30.
That's
Yes,
it.
sir.
Yes, sir.
That's
Sir,
it.
once can you explain how the above one became hydration, sir?
Three water molecules, na? You added. You added three water molecules, na?
Yes, sir, but hydration means we should get hydrated product, na, sir.
Yeah, hydrated product only. You have to write three water molecules here. Okay.
Yes, sir.
Yeah. Clear or not? Actually, here it
Yeah.
is not written. You are confused. Three water molecules.
Yes, sir. Now, okay, sir.
It's okay. Now. So this is what is lattice energy and hydration energy. You get the enthalpy of solution. So enthalpy of solution is nothing but enthalpy of lattice energy and also hydration. Hydration is nothing but cation and anion hydration. So this is how questions may come in the exam also. You can think of lattice energy. This is hydration energy of cation, hydration energy of anion. They give. Now dilution I explained already, right? I don't want to get into it. The enthalpy of lattice enthalpy is very simple. It is the amount of energy released. Released means what process? Exothermic.
Endotherm.
Exothermic.
Exothermic, sir.
Amount of energy released when 1 mole of crystal is formed from its constituent ions. So these are the constituent ions, na? Respect to ions. So 1 mole of crystal is formed from its constituent ions. So bond formation, crystal is forming, na? What attraction is it? Electrostatic attraction. Na?
Yes, sir.
So attraction, electrostatic attraction means energy will be released or energy will be taken up.
Release.
Attraction,
Release.
formation, energy will be released. So that's why it is always exothermic. Clear or not?
Yes, sir.
Yes.
So always, similarly, hydration energy, if you see hydration energy, the amount of energy released when the ion gets solvated. See, this is ion, for example, Na plus ion, let us take. Now water molecules are coming around. Water molecules are like this. When water molecules are coming like this, what happens to this? Bond will be formed.
Bond will be formed.
In another way also you can write. What is a dipole, you know? Dipole only,
Yes,
na?
sir.
Yes, sir.
Plus minus. What is a dipole? So there is ion dipole attraction. What attraction?
Ion dipole attraction.
Minus plus. Minus plus. Minus plus. This is a dipole water. Because what is like this, na? This is delta minus and delta plus. Agreed?
Yes, sir.
Yes, sir.
So naturally there is ion dipole attraction. So that's why what happens? Energy will be released. Delta H will be negative. So this is called hydration enthalpy. Are you clear or not? So lattice energy and hydration energy both are
Exothermic.
exothermic in nature. Are you clear, everybody?
Yes, sir.
So it is defined exothermically. Now listen carefully. Listen carefully. If lattice energy is more, is it easily soluble?
No, sir.
No,
No,
sir.
sir.
Listen carefully. Lattice energy is more means strength of ionic bond is also more. For example, examiner will ask this question. Listen very carefully. MgO NaCl, which is strongly ionic.
MgO, sir.
MgO.
Sir,
Because why? Mg is plus 2, O2 minus. Electrostatic attraction is more. So energy
Yes,
released
sir.
will be more. So delta H, lattice energy will be more exothermic.
More.
Clear or not? Now,
Yes,
Yes,
sir.
sir.
I'm changing the question. Ease of formation of ionic bond, which is going to be easily formed.
NaCl, sir.
NaCl, sir.
Easily formed is what? Low IP,
Less
Lattice
lattice.
high electronegativity.
Electronic.
Lattice energy only we see the strength of the bond, ionic bond.
Yes.
See my question. These and all have come in the exam earlier. Lattice energy decides the strength of ionic bond, not ease of formation of ionic bond. Ease of formation of ionic bond, the factors influencing are low IP and high electronegativity, which is having high electronegativity. Low
NS.
IP, low IP.
Yes.
Na and Mg, which is having low IP. Na.
Na only.
Are you following? So low IP, high En. Clear or not?
Yes, sir.
Yeah. So these two are different. Ease of formation of ionic bond is different from strength of ionic bond. Clear or not? See, when
Yes, sir.
hydration energy is more, then what happens? It is easily soluble than lattice energy. It is
Yes,
going to
sir.
pull off the lattice because lattice is weak lattice. Na?
Yes.
So when a strong lattice will be formed, energy released is more. That's why a compound to be soluble, hydration energy should be greater than lattice energy. If lattice energy is greater than hydration energy, the compound is very strong. Definitely it cannot be soluble. Are understanding subject?
Yes, sir.
Yes, sir.
Yes, sir.
Very good. So Born-Haber cycle, what it gives an idea? Come on. NaCl, MgCl2, CaO. Okay. In which case energy will be more, because calculation of lattice energy, U is lattice energy. Calculation of lattice energy can be done from which cycle? Born-Haber
Born-
cycle. Well, lattice energy, for example, here is minus 700, this is minus 1500, this is minus 200, 2000. So which is more lattice energy?
CO.
CAO, sir.
So that is the strongest. That is strongest. Strength of the ionic bond is strongest in CaO. You understood why Born-Haber cycle you have learned?
Yes, sir.
Yes, sir.
Yeah. This is the lattice enthalpy. Born-Haber cycle. What is Born-Haber cycle? Heat of formation is one step, is equal to IP plus sublimation energy,
Dissociation
energy plus
plus
electron affinity
Yes, sir.
plus
Electron affinity plus
lattice energy.
lattice energy, sir.
Is it all right?
Yes, sir.
Yes, sir.
Tell me the answer.
Option A, sir.
Yeah.
Yes, sir.
Lattice energy and hydration energy. Sum of the two, reverse of lattice enthalpy and hydration energy. This is minus. This is minus. You have to
Sir?
type. Yeah, please.
Sir, I have a query, sir.
Yeah, please.
So what is reverse of lattice enthalpy, sir?
Lattice enthalpy is generally negative, no?
Yes,
Negative
sir.
of negative becomes positive.
Okay, sir.
Clear or not?
Yes, sir.
Okay. Now, can you tell me
Both, sir.
Both, sir.
Both,
sir.
end by end.
both? Don't think this question has been asked in earlier some competitive examination, not a mains, but it is asked in other competitive. Now, so we'll solve some questions, okay? And tomorrow will be the last class for thermochemistry. Tomorrow we'll solve some numericals and we'll close. So today also we'll solve some few numericals now. 2-3 numericals we'll solve. Now the heat of neutralization of HCl by NaOH is 55.9. Now let's write here. The heat of neutralization of HCl plus NaOH. This value is given minus 55.9 kilojoules per mole. If the heat of neutralization of HCN by NaOH is minus 12.1, so HCN plus NaOH is given minus 12.1 kilojoule per mole. The energy of dissociation is. So 1 second, here something is given, mistake is given. I think this is minus 43.8. Mistake is given here. This is 1 second, wait. So the heat of neutralization of HCN by NaOH is minus 12.1 is given. Minus 12.1 actually should be minus 43.8. Let us see. Okay, minus 12.1 is given. Anyhow, this neutralization is given. Heat of neutralization. 1 second. This is heat of neutralization. Now try to understand. HCN is a weak acid. So to break this, it requires heat of ionization. Do you agree or not? Heat of
Yes.
ionization
Yes,
is
sir.
required. But heat of ionization actually, listen carefully. These two should be together minus 12.1 and minus 55.9. Minus 55.9 plus 12.1. How much is coming? This is 8.
So minus
43.
43.8.
43.8 minus 43.8. So this is the heat of neutralization. This is the dissociation. So mistake is given. Actually, this should be plus. This should be plus. This should be the heat of dissociation. Are you clear or not? So mistake
Yes.
is given. These questions are the mistake is there. So the heat of this is not neutralization. This is the heat of ionization. Then you have to find the heat of neutralization. So or else you can do one thing. Heat of neutralization must be how much? Minus 43.8. Then heat of dissociation will be plus 12.1. So his mistake is given here. This question. You understood or not? So heat of
Yes.
heat of dissociation is always positive. Heat of dissociation is 12.1 kilojoules. Okay. Minus 43.8 is the heat of neutralization for a weak acid. Clear or not? Yeah. Now, the dissociation energy of CH4 and C2H6 are 360 and 620. The bond energy of CC is very interesting question. See, this is CH4. This is C2H6. So, from this, how much is coming? 360 kilocalories is coming. Do you agree or not?
Yes, sir.
360 kilocalories is coming. So 360 is for how many bonds you are breaking here?
4, sir.
4, sir.
4 bonds,
360
sir.
by 4. 360 by 4 gives
90, sir.
90 kilocalories for 1 CH bond. 1 CH bond is how many kilocalories?
90, sir.
90 kilocalories is 1 CH bond. Agree or not?
Yes, sir.
Now listen carefully. Now in this question, listen carefully. Total how many CH bonds are there?
6, sir.
So 6 into 90 how much?
540, sir.
540, sir.
540, sir.
540. 540, right? 90 into 6 is 540. Now, what about the CC bond energy?
Yes, sir. The whole bond energy minus
Whole
CH
bond energy is 620 is given, na?
Yes.
Yes,
So
sir.
620 minus
Minus CH
540.
bond energy.
540.
That is
540
540.
will give CC bond energy.
Yes, sir.
Clear or not?
Yes,
Yes,
sir.
sir.
CC bond energy. Yeah. Now you can also do one thing. I'll tell you in another way. Easy way. Just listen. One second. Some issue is there. Yeah. So what you do is you do one thing. Now you write like this. Bond energy. One second. You do one thing. Delta H is equal to, help me, bond energy of reactants minus bond energy of products. Clear or not?
Yes, sir.
You can
Yes,
write
sir.
like this. The bond energy of reactant. Bond energy of reactant and bond energy of product. If you write then CC bond, this CC bond and all you can write from here. See, to break these bonds, C2H6, the CH bond you are writing from CH4. Clear or not? CH
Yes,
bond
sir.
energy, how do you are finding? Because it is giving total 360. So 360 by 4. So CH bond energy is coming from CH4, right? And total bond dissociation energy is given for ethane. So you can also learn from that. Yeah. Now one more question. Heat of hydrogenation of ethene is X1. Heat of hydrogenation of ethene is X1. Now listen carefully. Ethene. When you do add hydrogen, you'll get ethane. This is given as X1. Because heat of hydrogenation is a exothermic process. It will be minus X1. Any doubt?
No, sir.
No,
No.
sir.
Benzene is actually resonance energy is equal to delta H observed minus delta H calculated. This is the resonance energy, and the next session I'm going to teach this. Okay. Now what is required here? That of benzene is asked. Benzene means how many triple bonds will be there?
3, sir.
3, sir.
Three are there. 3 means this will be how much? Minus 3x2.
Minus 3x. 2.
Minus 3x2.
Yes, sir.
Minus 3x2. So resonance energy means that's what it is. One second. I'm sorry. 1 second. Yeah. So here, listen carefully. Now, so minus x1 is for 1 double bond. Agreed? But 3 double bonds, it will be minus 3x1.
Yes, sir.
So this is for benzene. Agreed? And this is for ethene. Agreed
Yes,
or not?
sir. Yes,
Agreed
sir.
or not? Now
Yes,
listen
sir.
carefully. Heat of hydrogenation of ethene is x1 and that of benzene is x2. So benzene is x2 is given. Listen very carefully. So x2 is what?
Calculated, sir.
And 3x1 is?
Observed.
Observe, sir.
So that's why you have to write like this. So delta H observed minus delta H calculated.
Calculated.
And you will understand more. So in the numericals to come, the tomorrow session. Okay. So you would like to solve one more question, last question for the day?
Yes, sir.
Yes, sir.
Yes, sir.
Last question. Okay. Now in this question, a very interesting question. C2H6 is given. C2H6 is what? C2H6 is
Sir,
what?
ethane.
Is ethane. So ethane combustion reaction is given. Okay. And delta S vaporization is also given. I'll take this up. This also I'll take up. Yeah. And now listen carefully. Heat of formation of water is given. Heat of formation of CO2 is given. Heat of formation of C2H6 is given. So what you have to find? Heat of combustion of
Ethane.
methane.
E2.
That is required. Yeah. So how to solve? So let us solve here. So first thing is heat of formation of water will write. Okay. Heat of formation of water, tell me. H2 gas plus half O2. 1 second. Let me take this up. I do one thing. I clear this. I'll write up. Yeah, here I'll write. So help me. H2 gas plus half O2 gas gives rise to H2O gas. Do you agree or not? Liquid, na?
Yes, sir.
H2O
Liquids.
liquid.
Yes,
H2O
sir.
liquid. Now, CO2, C graphite solid plus O2 gas,
CO2 gas gives CO2 gas.
CO2 gas. Next, help me. C2H6. C2H6 is 2C
Gas.
solid.
2C
Plus
solid.
Graphite, not
3H.
gas.
Plus-
Graphite. This is graphite. You soup. So
Yes.
plus
sir.
3H2
3H2 gas.
Plus
Gas.
3H2.
Gas
gas
gives
is
C2H6 gas.
C2H6 gas. Agreed?
Yes,
Now,
sir.
Yes,
now
sir.
what is required? Let us see what is required. So what is required is this one. C2H6 is which side?
So left side.
Here,
Left.
here, left side. So here which side is there?
Right
Right
side, sir.
side.
So
This
minus.
is
sir.
minus. This is
Yes,
minus.
Yes. Yes, sir.
Agreed. Now, CO2 is which side?
Sir, right side.
Right
The right
side.
side, sir.
Here which side is there?
Right,
Right
side
side
only.
only.
Plus,
This is
sir.
plus.
Plus, sir.
Water is which side?
Sir,
The
right
right
side.
side.
Right side. Here also right side. But 3
Right
into na.
side.
This is plus. But
Yes,
3
Yes,
into.
sir.
3 into 3.
3 times.
Clear or not?
So
Yes,
even
sir.
CO2 2 times, sir.
So now, but there is one problem. Now listen carefully. Now, can you see the answer now? Can you see the answer now? What is this X1? Delta S vaporization of water liquid. So liquid to gas.
Yes, sir.
Hello. In the product, what is there here? Gas, na?
Gas, sir. H2O gas.
Yes,
Gas.
sir.
So, but what you are getting here?
Liquid,
Liquid.
sir.
Liquid,
Should
sir.
be converted into gas, right?
Yes, sir.
Now solve this question. Now see, listen, plus 3 times this one. This reaction, how much is given? X2.
Yes, sir.
Is it okay?
Yes, sir.
Yes, sir.
Now, this is also plus CO2. CO2 is plus. So 3x
Yes, sir.
plus
Plus
X3.
2. Sir, 2x3, sir. Carbon dioxide 2 there, sir.
Yes, sir.
Carbon dioxide 2 is there. So 2x3. Is it okay?
Yes, sir.
Yes.
Yes, sir.
And minus X4.
Minus
X4.
X4. Yes, sir.
Right only, na? Minus X4.
Yes,
2x3.
sir.
Right, na?
Yes, sir.
Similarly, water molecule vaporization. Water molecule
Yes, sir.
vaporization is given how much?
Yes, sir. X1, T1, sir.
X1. But X1, how many molecules are there?
3, sir.
3. So that's why 3x1.
Yes, sir.
Clear or not?
Yes,
So
sir.
answer is B. This one.
Yes, sir.
Are you clear or not, everyone?
Yes. Sir, why they written
Yes,
T1,
sir.
sir?
Yes, sir.
Temperature, na? Temperature T1.
Yes, sir.
Boiling temperature. Yeah. So I hope you are clear about this. Okay. So I hope you are practicing this thermochemistry numericals. Thermochemistry numericals are easy actually. The technique is involved. So just a manipulation. So anyhow, thanks for bearing. Tomorrow will be the last class for thermochemistry.
Thank you, sir.
Thank
Thank
you,
you,
sir.
sir.
Good evening and thank you, sir.
Thank you, sir.